All right, good morning. We are doing more with proportions, like everything's a proportion. Turns out, so as a reminder, you had a worksheet on Friday, and we did the math lib yesterday. So if you have free time today and you need to finish those up and get them turned into the period 2 drawer, you should work on that. We are looking today at similar figures, which again is basically going to be setting up a proportion. And if you keep your proportion organized, then it works out. Really neat. So today we're talking about similar figures. This is sort of the first geometry thing that we've done. But similar figures are pretty nice. Similar figures have the same shape, but a different size. That says size. Man, that's terrible. Size. Similar figures have the same shape, but a different size. Figures are similar if corresponding angles are congruent. Have you heard that word before? No. It means equal. Corresponding angles are equal or congruent, and corresponding sides are proportional. So there's that proportion word we're talking about. All right, so the ratio of corresponding sides is called the scale factor. We're not going to use that too much today. But it is important that we set up a ratio of corresponding sides. So that's what we're going to focus on today. And so here we have a little example. We want to look at what things match up. So here we have a little triangle, we have the small triangle, and we have the big triangle. We have a small triangle and we have a bigger triangle. And what we want to look at is we need to look at, first of all, are they similar? And so to answer that question, I have to look at first all the corresponding angles. So what I want to say is we have these two triangles. You'll notice that they're sort of oriented the same way. We'll look at some that aren't in just a minute. And we have some markings, and I don't know if you've seen markings for geometry before, but you're going to get introduced to them today. You see this little arc here at angle A, at point A. This is an angle marking, and it's telling you that this angle A is the same as angle D. They have the same arc mark, okay? So those are called congruence markings, and they're telling you that those things are the same. So give the relationship of our corresponding angles. Angle A is congruent to angle D. That's what those arc marks mean. All right, this is a congruence symbol. It really just means that they're equal. It's an equal sign with a little squiggle on top. Call it a tilde. Okay. Did you? Yeah. All right. So, ladies and gentlemen, give me another pair of angles that are the same. C and F, yeah. Angle C is congruent to angle F. Angle C is congruent to angle F. Again, they have a triple mark. Gentlemen, they have a triple mark. So those angle C and angle F are congruent. Give me another pair of congruent angles. Yeah, angle B is congruent to angle E because, again, they have a double arc mark. So that is telling us that those angles happen to match. Okay, they are the same. So we do have three pairs of corresponding angles that are congruent. And we need to look at the corresponding sides. This is what we want to focus on today. Corresponding sides. Corresponding means they're similar, they're like the same position. Okay, they're in the same sort of position. So I want to look here. This side AB, has a side length of 4. Which side does that correspond to in the big triangle? Yeah, DE. It corresponds with the 8. They're sort of in the same position. We can also see that we have a single and a double arc mark below, single and a double arc mark there. So the side 4 corresponds with side 8. And because they're corresponding, we can set up a little ratio. Small on top, big on bottom. All right? Let's see. What side corresponds with the 7? 14, sure. And so once again, because they're corresponding, I can set up a little ratio. Small on top, big on bottom. So 7/14. And then, what side corresponds with the 5 side? The 10 side, sure. So we have 5/10. What do you notice about all of these fractions? They're all equal to 1/2. They're all equal. They're all equal to 1/2, which is very interesting. And this is what's true about similar figures. They all are the same ratio. And that's really important. Okay. So, we are going to skip down here to number 6. Now, because we know that the similar figures all have the same ratio of sides, we're going to set that up. Find each measure given similar figures. It's really important they're telling us we have similar figures. Because we have similar figures, I need to look at all the corresponding sides. Corresponding sides. That's what we care about when we have similar figures. So these two figures, these are quadrilaterals. These two figures have been oriented the same way, all right? It's very helpful for us. So if I look here, I've got my small figure and I got my big figure. So I'm going to start over here with the small figure. Which side corresponds to the side labeled 2? 3, yeah. So I can create a little ratio. Small over big, 2/3, so small figure, big figure. And that has to be the same as, again, I'm going to start with my small figure here. What does 8 correspond with? X. So I can create a little ratio, 8/X. This, ladies and gentlemen, is a proportion that we can solve. All we have to do is set up a nice little organized proportion. How do we solve the proportion? Cross multiply. You guys should be taking notes. We're going to cross multiply. 2 times x is 2x. 3 times 8 is 24. So we are cross multiplying. And then how do we get x by itself? Divide by 2. We get 12. X equals 12. And that's all we have to do. Find our corresponding sides and cross multiply. All right, let's turn the page. All right. What's the problem here in number 7? It's flipped and rotated and stuff. They're not oriented the same way. Do you see how they're different? Okay, but they are still similar figures. It might be helpful to make them orient the same way, but I'm going to, maybe I will. Let's see. Because they're marked, it helps us out a whole lot. So, first of all, I'm going to start with the X because that's what I'm trying to figure out. You'll notice the X side is on the side that has a right angle here, the little box in the corner, and the single arc mark. What side does that correspond with in this other triangle? Yeah, 11.25. Again, this is the side that has the little box in the side and the little single arc mark. Do you see how they have the same markings? Okay, that's what we need to pay attention to. So we're going to do X over 11.25. So I started over here with my figure on the left. And let's see. Let's see, I could pick 8. Which side corresponds with 8? 6, very good. Why do we know that? Why does 8 correspond with 6? Because of the markings. We see the box and the double arc mark there on that side with the 8. So again, with the side on the 6, we have the box and that double arc mark. So I'm going to write 8 because I started here on the left, and then 6 to the right. And ladies and gentlemen, that is our proportion. That is our setup. How do we solve for X? Cross multiply. So I'm going to cross multiply. 6 times X is 6X. And I don't know what 11.25 times 8 is. 11.25 times 8 is 90. And then what do we need to do to solve for X? Divide by 6, divide by 6. So we get X equals 15. All right, again, on number 8, these figures aren't oriented the same way, but they have good markings. So I'm going to say, hey, which side does the 14 correspond with? Yep, X. How do we know that it corresponds with the X? Because it's got a single and double. Yeah, so the markings there, we got the single arc and the double arc. So with the X, we have the single arc and the double arc. So I can write 14 over X for my setup there. And then, what side does the 10 correspond with? 15, very good. And again, when we look at the markings, we have the little box and the single arc mark. The box and the single arc mark. So those correspond, 10 and 15. And from there, we can cross multiply. So I'm going to do that. I'm going to cross multiply. I have X times 10, which is 10X. And then 14 times 15, which I don't know. 14 times 15 is 210. And we're going to divide by 10. Divide by 10, we get X equals 21. All right, let's look at number 9. Again, paying attention to the markings is really, really important because these two triangles are totally oriented differently. So I'm going to start with the X here. So I have my X. What side does it correspond to in the other triangle? 24. Very good. How do we know that? Yeah, so the X rests on a single and a triple arc mark. A single and a triple. And 24 does the same. It's got the single arc and the triple. All right. So then, let's see, I started with X. So 28 corresponds with 21. And again, 28 has a single and a double arc mark, and 21 also has a single and a double arc mark. So that's our setup. Pretty easy. And we can cross multiply. 21 times x is 21x. And 24 times 28, I have no idea. 24 times 28 is 672. How do I get x myself? Divide by 21. Divide by 21. So you get x equals 32. All right, last one, number 10. Number 10, last one. I will need to find x. I'm going to start with x. What side does x correspond with? 30? Let's see. And we know that because we've got a triple and a single arc mark. Oh, which 30? Does it matter? Oh, I guess it wouldn't matter because they're both 30, right? Yeah, okay, good. Single and a double, you're right, we had two of them. That's kind of interesting. But either one, because they're the same number, it wouldn't matter. All right, and then, let's see, I started over here with my right side figure. So that's the, I guess I'll pick a 5. What does 5 correspond with? 16, yeah, and again, we have two options here. Either one wouldn't matter. But we have the single and the double mark, the single and the double. And so there we go, there's our setup, and we can cross multiply to solve. So 16 times x is 16x, and 30 times 5, 150. I did know that one. 150 divided by 16, I don't know that. So divide by 16, divide by 16, we get x equals 9.375. All right, do you have questions for me? All right. You have a Delta Math. Don't want to do that. Just want to do. Can I please?